So what we're talking about now is a perfectly inelastic collision. Now, a perfectly inelastic collision is a collision in which two objects that are colliding stick together. And after the collision, the two objects that are stuck together move off as one big mass. So if you look at this type of example that I've got up here on the screen, we see that before the collision, you have a 10 kilogram object moving at 10 meters per second, and it's moving in the direction of a 5 kilogram object that's at rest. So before the collision, we have momentum, which is just from the 10 kilogram mass. After the collision, the 10 kilogram mass and the 5 kilogram mass are going to kind of stick together, and here they are stuck together. So they're stuck together. And the whole 15 kilogram mass moves as a one unit to the right with a velocity v. That's what we mean when we say inelastic collision, perfectly inelastic, they stick together. So let's see if we can find the final velocity of this 15 kilogram mass. That's a combination of the 10 and the 5 stuck together. We're going to do that with conservation of momentum techniques. And so let's do it with this color. So before the collision, we have momentum due to this mass, which is 10 kilograms, and it's moving at 10 meters per second. And we don't have the momentum due to this one here. P of this one is 0 because it's at rest. So mass times 0 velocity is going to be 0. So that's what we have before. After, we're going to have the 10 kilogram plus the 5 kilogram. That's going to be our total mass because the whole thing is one object now that's kind of stuck together. And that's going to be multiplied by some velocity v. That's the total momentum after the collision. So you see that this here is simply 15 kg times some v. And that's going to be equal to the momentum before, which is 100 kg times m over seconds. So there we go. Now we could solve for v. V is simply 100 kilogram times meter per second divided, whole thing divided by 15 kilograms, which is over here. And you can see the kilograms will cancel out, and you'll get 100 divided by 15 meters per second. And that is certainly going to be positive, so it's in that direction. And this is your velocity, which was solved by conservation of momentum techniques. All right, this is, again, perfectly inelastic, in which the two objects stick together.